Hello, hello. Uh, yes, so as you already know, in Swappie we are using Python a lot. And we're using, of course, the pytest because it's an industry standard nowadays. And of course, we're using Docker because, again, it's one of the most popular ways to containerize things. And today, maybe I will tell you a bit about how you can do the testing in a kind of more fancy way than maybe you are doing that nowadays. But who knows, maybe you are doing that already like that. So my name is Mikalai. I'm working in Swappie factory team. And in factory team, we are supporting all the things that is actually relevant to the repair of the iPhones. And here is just an office. You will not see anything interesting or relevant to the refurbishment or repairment. But in factory, you can see a lot of interesting things. We have robots, conveyors, plasma things, laser things, a lot of things. I have no idea what they're doing, but somehow I'm writing software to support all this stuff. So what we are using Docker for, right? So obviously we're using that to build the dependencies that we want to use for our software. So we want to run the test, and we want to run the test against the database. But at the same time, yes, that's fine, that's clear. We want to make the testing process and the way to run the test as easy and smooth as possible. So of course, we do not want to abandon containerization because it's convenient. Maybe you don't want to use Docker, maybe using something else, up to you, but the idea is still the same. You want to have a dependency, you want to test, and that's it. Of course, you have to run the dependency before you run the test session, right? So that's also obvious. And you are lazy, you're busy, you don't want to learn how to spin the dependency in a specific CI/CD, whatever you use, Jenkins, GitLab, whatever, it doesn't matter. You just want to run the test. Maybe in a company you have multiple environments, multiple teams. Maybe for some reason you have to temporarily join another team and you have to learn the things they are doing there. Disgusting. And actually, we would like to have the control, how we're using these dependencies. So this is going to be the foundation of all the slides that I have here, is that with the approach that I'm going to display in the slides, you have the full control of the dependencies that you're using for your tests. So you just want to run the pytest, right? You don't want to have this shell script that will run Docker compose something else, and no, just pytest. That's normal approach. It should be a normal approach. So here further, we're going to talk about this project. Maybe you're using that, maybe no, but if you're not using that, take a look. It's a good one. It's focused on the pytest and Docker specifically, but this approach can be actually scaled to any other way to run the test, maybe unit test, why not? And not specifically Docker, but the idea is just that. We are running the Docker using the fixtures. So by fixtures, where you can control the life cycle, you can control like everything, you have the full control over the dependencies that you have. So you have the test that is using, for example, database. So start database right now. Don't start it before upfront using some kind of shell script. You don't need it there. You need it now. So start it now. And this is the idea of all this library. It's super simple library. You don't have to be, I don't know, a very sophisticated engineer to understand what it's doing. But all the things that I'm going to display later are based on top of that library. So technically, we have 1, 2, 7, right? 7 fixtures to work with. Again, this is specifically about Docker, but the idea can be applied to any other containerization technique, right? So these are fixtures. You can override them. You can do whatever you want. So you are in control here. So the first one is just the fixture that contains the string. Just the command, actually just Docker compose, if I'm not mistaken. Docker compose file is the path to the YAML file that is describing the dependencies, and so on. I'm just not going to stop here so you can read. What this approach is giving us. So everything is managed by the test itself, not by some preparational scripts, not by CI/CD. Of course, you can still do some optimizations in the CI/CD, but the idea is still that everything that is relevant to the test is under the test control. You need fixture? Here you go. You want dynamically generate YAML file, put it in some temporary location and just use it from here? Go ahead. Everything is under your control. So to accompany the way how you can use the pytest Docker, there is just some public available project. It's very simple. It's available here. You can take a look at that later. And yeah, so the pytest Docker is very convenient because it's very simple. It's just a few fixtures. You're using these fixtures. These fixtures are just running the Docker for you, preparing the dependencies, then killing the dependencies. That's it. Awesome. Very super simple idea. But there are a few let's call that not issues, but things that you can encounter if you're going to use that. Maybe you're going to use this pytest Docker thing just as a basis for your own package that you can build on top, because it's very simple and it definitely can be improved. So because of the way how this pytest Docker is implemented, when you're using this, you can encounter the problem that when you're running the test, the Docker can prepare the dependencies, run them, but if you will kill the testing process violently, let's say, with kill or something like that, the fixture will not manage to properly finish that with Docker down, right? So you'll have a dangling process that is existing somewhere in your system. And this is kind of bad because every test session should be separate, right? And unfortunately, in the original implementation of the pytest Docker, there is no way to mitigate that. But because this thing is just like the collection of different fixtures, what we can do, of course, we can override them. So let me switch to the demo project. Please let me know if you have to make something bigger, right? Okay, so let's start with just the tests, first of all. So this is very, very simple code of the test. So we have some class that is doing the info command. So that's it. If you're familiar with Redis or similar services, there is a command called info. So you can call this info and the service will return you the information about the service itself. So for this demo, what we're going to expect? We're going to expect that we have two tests. One of them is here, another is here. One of them is expecting that we have a run in Redis. Another one is expecting that we have a run in KDB. It's kind of Redis, but it's not Redis. Both of them has the same behavior. Both of them have the same info comment output, but there are, of course, differences. So what we want to achieve? We want to achieve that we have running services. Yeah, that's obvious. And as you can see from the code, the Redis URI and KDB URI are going to be the fixtures. This one and this one, right? So that's also clear, I guess. Yeah, I'm expecting to do a bit familiar with pytest. So if you're not familiar with that and how it's working, then things are going to be a bit complicated. Sorry. So let's take a look at the YAML file that we have, right? So because we're going to have Docker to run the dependencies, we are going to use a regular Docker Compose YAML file that is going to just install and expose two services. One is Redis and another is KDB. We're going to expose them in some ports. We don't know. Maybe we're going to work in the environment where we have a lot of dependencies. Maybe they can clash somehow. So we are defining just the range of ports. So like that. We don't know. It's just going to work. That's it. Okay, let me. Yeah, so we have an idea what that test looks like. So we have an idea what the Docker Compose we're going to use. Now, let's take a look what our pytest Docker can do, right? So one of the first things that you will notice when you're using this library is that when you're spawning the dependencies using it, it's assigning the Docker Compose project with the random number that is just a PID of the pytest process. Because we want to achieve the following. We want to achieve the situation when if for some reason, if our pytest process has died and we have the dangling process, the simplest approach how we can kill these dependencies, just identify them and kill them. So we have to override Docker Compose project name fixture because it's fixture. You can do whatever you want. You can override it, and the behavior will be the one that you define for it. So instead of allowing pytest Docker do that for you, you're doing it yourself. That's of course not ideal to share the code here, but it is what it is. Get Docker services is not in fact the fixture here, but unfortunately you have to redefine it as well. Because by default, this context manager, what it's doing, it's spawning the dependencies in the very beginning of the life cycle of your tests. Then you can do whatever you want with the tests. Then it's just cleaning. So we have to alter the behavior of this context manager. It's just, in fact, the copy paste of the original context manager with few changes. So what we're going to do, we're just going to do the cleanup in the very beginning. So if there will be some dangling dependencies, it will do just cleanup, and that's it. So every test session now to be guaranteed to be executed in the fresh testing environment. Yeah, that's a lot of code to do this simple thing, I know, but if you are going to use this particular library, this is how you have to change the things. That's why I have mentioned that, because it's very simple for your purposes. You can just implement something by yourself, because this idea is still remains the same. You are not allowing to someone else to define the dependencies for you, to define the environment for you. Instead, you are in full control over the dependency. So this Docker services is the fixture that is like the core fixture when you're going to use this project. And because it's depend on the context manager get Docker services, that's why we had to redefine it before to do this cleanup. Yeah, that's a lot of code just to make sure that you don't have any like dangling dependencies. But this is how you can do that with pytest Docker. Okay, the second part is actually very simple, but let's just stop here a bit, because you want to know where your YAML files are. You want to control these YAML files, because these YAML files actually define in the way how the dependencies are going to be executed. You can pass the environmental variables to configure some settings. You can do whatever you want. So it's kind of important. So that's why I'm just going to stop here a bit. How can you define the path to the YAML file? So in this demo project, it's just a regular file that is just sitting in the path on the hard drive. So nothing special here, but just take a look. So yeah, as I have mentioned, because that's all the fixtures, right? So right now, I have defined that to be valid for the whole session, right? So this Docker Compose file will spawn some dependencies, and these dependencies will live for the whole session. But who knows, maybe you're working on some very large monolithic app that is shared between different teams. Maybe you have your own like goals, your own dependencies, who knows? So why not to define something that will not have a scope session, but scope, I don't know, module or something like that? Then within the same project, you can have multiple different dependencies, and all of them will be managed by you. That's cool. Another, oh, sorry. Oh, okay. For some reason, this is absolutely unclear to me. This plugin doesn't contain any utilities that is allowing you to work with async code. Nowadays, Python is async based, right? So of course, there are projects that are old enough to be changed to be async compatible. But well, nowadays, when you're starting something new, very likely async will be the core part of your functionality, right? And for some reasons, this project doesn't have anything that is allowing you to work with that. So that's weird, but it is what it is. Under the hood, when we are spawning the dependencies, all these fixtures are going to ensure that dependencies are actually available. So you have to provide some utility that will talk to the dependency and will return you some response that, okay, that's alive. So let's proceed. Go ahead and use it. There is an existing utility. So it's the part of this Docker services. Should I do anything? Thanks. So yeah, so there is a utility that you can use. It's called ready until responsive, but it's completely synchronous. So if you want to have the asynchronous code, and if you remember, our tests are also asynchronous, and we're using the asynchronous Redis client. Of course, we have to somehow handle it, because we do not want to use the asynchronous packages for tests and asynchronous for the code, right? So in fact, you just have to re-implement the same wait until responsive using async approach, and that's kind of ugly. But again, as I have mentioned, this project is kind of simple, very simple. And again, because it's Python, everything can be changed. So what we have here, we have some our so it's working with some delay for some reason. Okay, so we have our own function get res like service URI that is just defining some inner function is alive that is just doing ping, and that's it. So this function will return URL if service is responsive. If we can ping our dependency, then it's alive. That's enough. We can work with this Redis-like service. That's all we need. And the fanciest part, what if we want to run the tests inside the Docker container, right? So we're using the dependencies inside Docker. But what if for whatever reason, we want to pack the code itself that is running the tests also inside the Docker container? Of course, we can do that. Actually, that's the most trickiest part, because you have to know how the Docker and its network is working. That in many cases is absolutely redundant information that you can just don't care about. But here you have to know. Luckily, we have this demo application, and the link to this application is in the slides, and it's public, so you can just use it as some kind of helper. So the idea is that you are not going to run the Docker inside the Docker. Instead, you are going to just ask the host with the Docker runtime, Docker-G, to run the dependencies for you. So you have the host that is running the host that is running everything. It's running your tests, and it's running your dependencies. It's running everything. For that, you just have to, it's called mount, if I'm not mistaken. You have to mount the socket file that is used to communicate between the Docker client and the Docker runtime within your container. And of course, you have to put the Docker client inside your container that you have with your tests. So within the Docker with tests, you have the Docker command, and the Docker command, because the socket file is shared with the host, actually it will ask host to do something. A lot of blah, 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 blah. And another thing, especially if you're running that all the thing on Linux, because I know in Windows and Mac it a bit different. I just have to return back to the slides for a second. So, yeah, so we'll have this situation, right? So we have the Docker-D that is host, that is managing like everything. We have the continuous tests, and we have dependencies. So how can we now connect our test to the dependency? Because everything is managed by the Docker runtime. First of all, of course, we have the bridge network, so-called bridge network. So every container within bridge network can communicate with other containers. So you can just write more fixtures, helpers, whatever, that will execute more Docker commands for you that will help you to identify the address of the dependencies for your tests. So if it's default bridge or it's like custom bridge, there is like difference. But the idea is that you still have to do some extra work to figure out where my containers are. But there is another approach because again, because we're within one network managed by the Docker runtime, we can, and because all the ports, right? If you remember the YAML file, we have exposed the ports, and the ports are exposed and are available on the host with the Docker runtime. So we can just go like that. We can go to the host and go to the port that is exposed in this host to actually connect with the dependencies. It's a bit trickier, at least it looks like a bit trickier, instead of just doing how it's supposed to be. But at the same time, it's easier because it's just kind of a little hack that you have to do to achieve that. And this hack is here. Yeah, so on Linux, you have to very likely run the Docker run with this at host Docker internal, host gateway. This will allow the tests running in your container to actually communicate with the host. Otherwise, it's just not available. And it's specific for Linux. If you're using Mac, I'm not using Mac, but I've Googled, and people are saying that for Mac, there is no problem like that. But for Linux, it is. And if you run the Docker run, blah, 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 like that, you'll be able to access the host like that. So this will be the host name of the runtime, the host machine with the runtime. And otherwise, it will be just Docker IP, which is by default localhost. Docker IP, by the way, is also a fixture. You can, of course, change it. And the final part. So if we are connecting to the dependencies like I have described using this fancy part, we have to know the exposed ports, because otherwise, if they will be like the same bridge network, you can just go directly. It will be just, in case of Redis, it will be 6379. In case of KDB, it actually will be the same port. It will be just different host names. So you have to go there, and that's it. But because we are going to the Docker host instead, right? So we have to again ask the Docker, okay, guy, we know that there are dependencies exposed with name Redis and KDB, and these are the ports. What port have you assigned as exposed one that is acceptable for me? And all these, like, now gathering together. So we have a lot of fixtures that we had to hack in order to be able to reliably, in many, many, many cases, connect our dependencies. So that's what the content of the conf-test.py, which is the container for the fixtures we have. So just simple demo. Let's try to run the tests, right? So that's it. Yeah, that's kind of stupid, but in the background, what has happened is that we have asked Docker, please spawn the dependencies, then queue the dependencies. And we can do the same now running that same thing in the Docker, right? Because there's like large section in the conf test about how to do that. So just, I don't remember honestly, but I have added the example of the command to the README. So what we're going to do here, we're just, there is also the Docker build file within the root of the project. So what we're doing here, we're doing the new image that is containing our tests. And then we're saying, please, Docker, run the command pytest within this fresh image using this fancy things. That's it. So what you have seen here, same result, absolutely same result, but now it's running within the Docker container, which is fascinating. Okay. And that's a lot of code, right? And you might ask me, well, is it really better comparing to the just simple shell script that will just prepare everything and that's it? And the answer is, well, to be honest, it depends. If you want to have the full control for any reason, especially if you have very complex environments, we have different teams, you have to run dependencies in different modes. You want to see how, depending on the different settings, these dependencies are behaving and how your code is behaving. What will happen if, for example, when you have the running application, for some reason your dependencies is dying. So that's very easy to do because you have the full control with the fixtures. You can just run the fixture to just kill Docker. That's it. So dependency will die. What will happen with the application? So you have the full control over the dependencies. Do you need it? You can use this approach. It's not necessarily going to be implemented with pytest or with Docker. It's just like an example what you can do if you're going to use the pytest Docker, and what like minor things you can tune there if you're going to use it. But the general approach is that. And I guess that's it. Thank you.